Hi and good morning. We are going to continue our lesson 9, and we will cover pages 234 to 235. There is only 2 pages for this session. This session topic is the extraction of metals by electrolysis. In the previous part, we learned that there are many methods to extract the metals. So here we are going to focus on the method called electrolysis. We learned about the electrolysis in the previous chapters. So in this method here for extracting metals, we need to use because some reactive metals cannot be extracted by carbon. So they make a very strong connection with the other components. So it's not easy to extract by using carbon, using reduction methods. So it is required a lot of energy to break down the bonds, the connection between the metal with other components like oxide, chlorides, or any other halogens. So that's why we are going to use electrolysis in this case. So this energy is best supplied by electricity. So electrolysis actually made by a part which is battery and produce electricity to run the process. And extracting metal in this way is three-stage process: mining the ore, and purification of the ore in the factory actually, and the electrolysis of the molten ore. And in this part here, extracting of the metal by electrolysis is expensive, yeah, because it is required energy from battery, electricity, and many other facilities. So it's expensive actually, but is the best option for extracting reactive metal, as I said. And all right, where yeah, therefore this method can be launched in the area which there is hydroelectric power is available, like near the river or near the the places which they use the water to produce power and electricity. So in that area, that regions can be a good place to extracting metal, and can be um, the factories for extracting these types of metal can be launched there. And as we know, aluminium is the second most widely used metal after iron. The first is iron, and second is aluminium. Aluminium is the most important example that can be extracted by electrolysis. The extraction of aluminium, the major ore that means the natural compounds which contains of the certain metal. For example, bauxite is the major ore which contains aluminum. That means it has a lot of aluminum, and the best resource to extract aluminum. So as you can see at the bottom left is the electrolysis used for extracting of aluminum. And on the right side here, also the name of this process is called Hall-Herlot process. So there are totally three stages. The first is Bauxite is treated with sodium hydroxide to obtain pure aluminum oxide. So first stage is obtaining aluminum oxide from bauxite. Bauxite has many other things, maybe oxygen, maybe another metals like copper or iron, something else. But first stage is extracting aluminum oxide, which is called alumina. If we treat the bauxite, actually make a reaction with sodium hydroxide. Then the second stage is purified aluminum oxide is dissolved in the molten cryolite. Cryolite is sodium aluminum fluoride, this one. So we need to purify it. After obtaining aluminum oxide, then we need to purify aluminum oxide. This is the second stage. First, obtaining pure aluminum oxide. Second, purify aluminum oxide. Then but you can also look at closer to um, cryolite is used to lower the working temperature of the electrolytic cell. So why we use cryolite? It can be a critical question. Why in the second stage cryolite is used? What is cryolite? Cryolite is sodium aluminum fluoride first, and second we need to know why they use to reduce the working temperature. At the normal condition, it is required about 2030 Celsius temperature, but when we use the cryolite, so the temperature can be reduced to 9 to 100 Celsius. So reducing temperature means we can save more energy. We will not waste the energy. So this is the reason why cryolite is used for this process. The third is molten mixture of aluminum oxide and cryolite that been used is electrolyzed in a cell fitted with graphite electrolytes. So electrodes is made of graphite. So this is another point that you need to consider. The electrodes here made up graphite. So at the bottom of this page there is two important reaction happen in the electrolyte electrolyte cell. So next slide shows you more details about this reaction. So aluminum ions are attracted to the cathodes. At the bottom of um, this electrolyte cell, you can see there is a carbon cathode. So aluminum need to attack to the carbon to discharge from the liquid aluminum. That means when aluminum attack, then lose the electrons here. Okay, give the electrons and become aluminum. So we'll convert to the aluminum with a neutral charge. It's not positive and it's not negative. But the first aluminum 3 positive cation form need to attack to the carbon cathode to get electrons, to receive electrons, and then becomes aluminum. The second reaction is oxide ions are attracted to the anodes. The other part here you can see two parts which are anode. So here, where they discharge to form the oxygen gas at the high temperature of cell, this reacts. Okay, and then there is a carbon, as I said, graphite used in anode. So graphite actually is a pure carbon. So pure carbon, which is form of graphite. Graphite is a form of pure carbon, but it's very soft. On the other side, there is another form of carbon, which is diamond. Diamond is very hard and a very hard form of carbon. Both are made of carbon. Graphite actually used in anode to react with the oxygen from aluminium oxide. Here, if you see aluminium oxide, we have a molten aluminium oxide. Here you can see liquid aluminium, which is aluminium oxide. So aluminium here are attracted to the cutters, but here oxygen, the rest of the compound, are attracted to anodes. Okay, react with the anode part to produce the carbon dioxide. Carbon dioxide is a form of gas and can released from the experiment. There is another industrial electrolysis process for anodizing aluminum. So sometimes we need to protect um, um, some metals, so we need to cover it with other types of metal to protect against against corroding. In the last part, I explained about the corrosion of metals. So this electrolytic process can be used for anodizing aluminum. Also can be used for another types of metal like tin, like other one. So if you for example, if you buy a tuna can or bean can from the market, and then if you check the can, you can see, if you scratch the surface by a spoon or by knife, you can see there is a very thin layer of protective layer on the metal in the on the can. So after you're scratching, you can remove the thin layer of the the thin layer on the outer surface. So that one also can be obtained by this process, electrolytic process. So it's good to protect the some metals that are reactive with the air, the oxygen available in air. All right, that's all for today. Please look at this question. These questions are very useful while I'm explaining this part. These questions are related to this part today. So you can practice, you can use this question for your memorization. So that's all for today. Take care and stay safe at home.